shelves in the chamber. The top shelf is connected to a bus bar on the right, which is connected to ground. So the top shelf is grounded. The second shelf down is called the direct shelf. That shelf is connected to a bus bar on the left, which is connected to the RF power supply. The third shelf down is a grounded perforated grid. The fourth shelf down is the indirect shelf. It is floating, it's not connected to ground or RF. The grid above it takes away the charge that gets to that shelf. You get a plasma through the whole chamber, but on this direct shelf, ions are accelerated towards that shelf. When you break up oxygen, which is O2, into individual oxygen ions, it's oxygen with electrons stripped from it. They're attracted to the bias on the direct shelf. So they hit that shelf with a lot of energy. It also heats up the samples on there, so you don't want to do a real long run on there. The grounded grid takes away that charge from those ions, so that down on the bottom shelf you basically just have free oxygen radicals with not much energy in them. They slowly etch away the surface just by a chemical reaction, but there's not a lot of energy and not any acceleration on that shelf. So most of the work you're going to be doing is going to be on the direct shelf. Now you need to enter all the parameters for the run you're going to do. You're always going to start out in program number 1. There's a laminated card that's kept by the machine that has the information you're going to need to enter these parameters. In the center cluster is where most of the parameters you're going to change, and the ones on the right are for the gas flow. So when you hit set, and you're going to go scroll down through that list of parameters, make sure you're in program 1. So you're going to start at the top, and you're going to use the up and down keys to change it if necessary. The top should be 0. The next one down, I'm going to do 75 watts. So that's 75 watts for the power. 100 for an endpoint. This is for a feature that we don't have, so it should always be at 100. 60 is the time in seconds. You would use the up and down keys if you want to change that time. The next one down is DC bias. That should be at 0. And then 85 is the base pressure. That should always be set at 85. That's the pressure that the machine will pump down to before you start the run. So when I'm done programming, I like to leave it on the top position there, turn off the set, and now that gauge will show you the pressure in the chamber when it starts pumping down. Right now it's out of the range of the pressure gauge, so what it's doing is showing a memory from the previous run. Now you're going to enter the gas flow. Gas 1 is nitrogen. You always want gas 1 to be 0. Gas 2 is oxygen. That's typically 2, 3, or 10. I'm going to leave it at 2. That means 2 SCCM of oxygen for the flow. Gas 3, 4, 5, and 6 are not used, so those should all be 0. I like to leave it showing gas 2 with the set button off, so when you're actually doing the run, it's going to show the flow in SCCM for gas 2. Then you hit start, and now the whole process is automatic. A little time's gone by. Now this is showing that the pressure is falling. You can see press is lit up on the row of buttons on the bottom. Now you're just waiting for the pressure to fall to 85. Now it's one tick below 85, so now it's at 85. As soon as it gets to 84, it will start the process. Now it hit 84, so it turned on the gas. The pressure jumps up at first, and the machine will let its gas flow stabilize for a little bit to get a stable pressure. Once it thinks it's stable, it'll turn on the RF plasma. You can see on the right that there's a flow of 2 SECM of oxygen. Now the RF plasma is on. You can take a look in the chamber and look at the plasma. This is a typical pale pink glow that you should see in a normal oxygen plasma. If you see a really bold purple plasma, it usually means there's a nitrogen leak or somebody accidentally entered an entry for the gas 1, which is nitrogen. When the run is done, it will start venting automatically with nitrogen. The nitrogen comes out at a pretty high pressure, which will rattle the door. So hit stop and that will save nitrogen. If you don't hit stop, it will stop on its own after about 1 minute.